growing more and more, the cloud server will overload. So it is why we need the AIoT. When we use AIoT, we can deal data in the edge, just like the edge computing. Yeah. Now, what is the AIoT? We know about AI and IoT. AI is artificial intelligence. In the recent years, it's usually talk about with the deep learning. Deep learning, usually in the computer vision, the deep learning have successfully solution following problems about object classification and object detection and object segmentation. Also in the audio side, deep learning can handle ASR, which means the auto speech recognition and data analysis, also with the automatic of many device control. Here is some pictures you can usually see in the computer vision. This picture shows the typical 10-euro flow. It detects the dog and the bicycle and the car in the picture, and this picture shows how the deep learning find the future from the picture. It uses several network stack to find the deeper future inside the picture. In the other hand, IoT, which means the Internet of Things, I'm very familiar with IoT because I have do IoT company last 3 years, and I just come from IoT company to now to the Sipeed company just last year. In the past 3 years, I have worked for Wi-Fi, BLE, LoRa, NB-IoT, and Sigfox. This is those IoT solution. They usually based on ESP8266 or ESP32 or XX1278. If you ever used Node MCU, this open source hardware project I have take part in this open source hardware project too. In the IoT applications, the communication method is important. We just introduce about Wi-Fi, BLE, and so on. In the other hand, the sensor and architecture and the network is 3 important parts in the IoT application. Sensor, I think you are very familiar with the sensor because you are in the MEMS sensor application, and the network is my subject. We usually use Wi-Fi merge or BLE merge or low language in the real world application. Both of these IoT things they collect data they collect data in the real world and post the data to the cloud. So all the data analyzed is on the cloud. It will case the network may be overload. To slow to what is the solution of the overload of network or the server? It is AIoT, edge computing, or AI plus IoT. In the one hand, AI is powerful. You must know about NVIDIA's card. For example, 1080 Ti, it have about 10 TOPS. It means this card computer 10 power 12 times every second, and the more powerful is DGX card. It's even thousands faster than the normal card. But it's also case high power consuming. Usually, the single card costs 300 watts, and the DGX costs 10 kilowatts. It's a very high power consume. Also, the card is very expensive. They usually from $1,000, and also AI need AI need big data. We need a very huge amount of data to train the network. Or we can say the AI consumes the data. In the other hand, we can say the IoT is the data producer. So the IoT produces the data, and the AI consumes the data and will generate the network to predict the data. The AI is the AI we talk about is most focused on training and inference. But in the IoT world, we mostly use about the inference. The IoT device is very different from AI device. IoT device is usually very lightweight. Normally slower than 100 frequency, or in the 100 million OPS. It is thousands times slower than normal AI cards, and it is very low power consumed too. We usually, when we talk about IoT device, we usually the customers usually requires the device work for months only, and only several batteries to power on them. Also, the IoT device is very low cost, normally from $1 to $10, because the IoT device have large amount. It requires very low cost per node. We can see many difference from AI and IoT. So the traditional chip counterfeit both requirements in the same time. In the same time, for example, the high power consume and low power consume, expensive and low cost. yeah, it is very different. So we need new chips to. So we need new chips to feed this application. And the recent years, some AIoT ASICs is come out. Here is some example of those chips. The first class is coprocessor. The coprocessor can't work alone. It needs a host chip, or we call the AP chip. For example, the famous one is Google TPU Edge, and also Intel have married a chip. It's usually made as a computer stick to accelerate the AI inference speed. Also here is have also the light speed is Chinese AI chip. It's also used in computer stick too. So the co-processor is priced about $15. It's still a little expensive when you want to use them in the LT node. The second class is AP chip. And so the chip can work alone because they have the whole so they also call the SoC because they have whole things you need to run Linux. You can see the example is RK3399 Pro. It is very famous last years. And Jetson Nano is from NVIDIA. And Bitmain BM1880 is from Bitmain. Bitmain is very famous in Bitcoin, but they also design these AI chips. Those class chip is about $10 for the chip only, and $100 for the development board. The third class is MCU with AI. I think this class is more suitable for AIoT application because they are cheap and powerful, as they have balance on the price and power. Here is some example: Kendryte K210 and AVS DSP, GAP, and the current KL520. They usually under $5 chip only, and when you make those chip to the development board, it costs about $10 to $20. It is even cheaper than Raspberry Pi, but it have about 1 TOPS. You know, T is 10 power 12. It is thousands faster than normal chips. Kendryte K210 is the chip we choose. Why we choose this AI chip? In the one hand, the chip designer is my friend. We have take part in the chip design in the past years. This chip is released last year September, and we have worked together from 2 years ago, and and this year we are focused on focus on developer on this chip to make it more easy for normal user to use it. But at first we will talk about this chip. Chip is advantage. This chip most chip you know is based on Intel x86 or the ARM kernel, but this chip is based on newest RISC-V 64-bit kernel. It's clocked at 400 to 600 million frequency. It is quite quick for an MCU. It is also dual core. In the AI computing power, it reached about 213 G. MUL means multiply, because multiply is the most complex application in the AI network computing, and the total power is about 1 TOPS. Also K210 have FPU double and single, and the APU means audio processor unit. It's about 8 meg area. You can use K210 in the ASR application, or you can you can do the sound imager use the 8 meg area. Also, it have hardware FFT. You know, FFT is very useful in the audio application. K210 is made in very low power 28 nm CMOS technologicals. It is why it have 1 TOPS computing power, but it's only consume about under 1 watt. It's consume about 5 voltage, and it will cost about 100 milliamp. So it is about 0.5 watt in typical application. It is very low power. Here is cheaper structure. You can see DMA, DVP. DVP is the camera interface, digital video port, and the tag for debug. AES is encryption unit, and OTP. We use OTP is OTP has a function to encrypt the chip. FPLA is the function to mix I/O to any function you want. SRAM. This chip have very large SRAM. Is about 8 megabyte SRAM. SRAM is different from DDR. SRAM is very more faster than DDR in read address, read or write, and low power consume than DDR. It is why K210 use SRAM. Also, SRAM is very expensive, but the K210 control its price in $3. Here is a 50 APU and some common preset like GPL, UART, SPI, RTC, RISC Tanner, PWM, Watchdog, and SHA-256. Now we start introduce about our open source AIoT project. Shenzhen Sipeed Technology is focused on two parts. The first part is AIoT solutions about, for example, face recognition, car license recognition, ASR, sound field imaging. It's a typical application. And in the other hand, we do many open source hardware software projects. Here is 4 parts of open source projects. First one is MEMS. MEMS is our AIoT project based on K210. It is from $10. And second is Tang. Tang project is FPGA project from $5. It can be run RISC-V soft core. Third is Longan project. It's a RISC-V MCU project. Last is the Leech project. It is common Linux SBC board from $5. Here is our GitHub repo, and we have do Indiegogo projects last year. Here is our Max bots. First, we introduce about cobots. Here is the Max One and the Max One Wi-Fi. We call it M1W. It is very small. It is about 1 inch square. You can see the main chip, flash, DC-DC power chip, and the Wi-Fi chip, and the reset chip on 1 inch square. And here is Max One NGFF module. We call it M1N module. It is about it's even smaller than M1, and it is use golden finger. You can see you can replace this module easily. Just plug in the socket. It also has a camera slot on the board. The following is the simple development board. This one is MaxBit. Its advantage is breadboard compatible. You can see it have Type-C interface and onboard serial port. It is USB to TTL chip and onboard MEMS MAC. It is onboard MEMS MAC. Then here is flash main chip and the 2 FPC socket. One is for camera, one is for LCD. This board is breadboard compatible. You can plug it into breadboard and connect lens for for your test. Here is the original Max dock board. It is all-pin breakout. You can use it for basic experiments. Last one is our Max Go and Max Duno board. Mexico is full function development board with PMMA case. It has larger screen and with the touch screen and M12 camera, and all function is in this board. Last one is Maxduino. Maxduino is Arduino compatible board. It also have ESP32 on the board. You can see the structure in the bottom of the PCB. It have two cores, AI cores and Wi-Fi cores. It can connect to camera, TF card, DC-DC power, inverter, and AI part and Wi-Fi part communicate with SP and UART. It also have MEMS MAC and RISC-V PA on the board. Can plug a speaker to make sounds.
So I want to add some comment for this MEMS microphone. I think it's made by our UST students company, right? 这敏星半导体 right?
Yes.
Yeah. Li Gang, he actually the CEO and founder of this MEMS sensing in Suzhou actually is a graduate from our Professor Meng Wang's lab in our UST ECE department.
Okay. Oh,
yeah.
It's very interesting. And next we will introduce our software. We have two open source software development. One is MaxPi and one is Maxduino. MaxPi, we just use MaxPi because most AI API is in Python interface is more easily to use. MaxPi is based on MicroPython. MicroPython is a simplified Python environment. It's usually used in embedded systems. And MaxPi is a script language. It is easy to code. You can you don't need compile the code. You just rest the code and run. We also have the OpenMV API compatible. MaxPi have merged OpenMV API, so you can, if you have used the OpenMV before, you can use its API in the same way. And we also have IDE for MaxPi. You can view the image both on IDE and LCD. We have just said it is friendly for AI APIs. You know that TensorFlow or Coffee is based on the Python. Yeah, if you are familiar with TensorFlow, you will easy to use MaxPi too. Second is Maxduino. Maxduino is the part of Arduino. We port Arduino to our boards. The software environment can be run all boards, all the Max board. You can run both MaxPi and Maxduino in our boards. Maxduino is Arduino compatible and also support platform I/O IDE. I know you may be familiar with Arduino's original IDE, but the platform I/O IDE is quite easy to use too. But the Arduino API is in C-like format, so we just port basic AI APIs. The AI APIs is not not so implemented than the MEMS. So we suggest to use MEMS to develop AI applications. Here is some reference. It is our wiki. This wiki I can. Here is here is our wiki website. You can see many instructions in this page. This MEMS points to the MEMS.sipeed.com is for MEMS wiki, and here is MEMSduino.sipeed.com for MEMSduino. The MEMS wiki have more complicated. And here is our GitHub repo. We can the open source project is in this repo. For example, the wiki SDK and the top box, MEMSduino project, user memo, Kflash GUI is the downloader tools, and the MEMS project. MEMS is total open source. You can even compare yourself MEMS from this project. And the MEMS scripts is the example for MEMS. You can find all the demo code in this repo. Yeah, for example, face recognition, find the green globe, image, scan QR code, and so on. MEMS, and you can download the MEMS firmware in our download site. We have two download side. One is it is DL means download. DL.sipeed.com is for global download, and the cn.dl.sipeed.com is for Chinese download. We have two servers, yeah, for different location user. I'm in China, so this website will slower and this website will faster. You can click to the paths you want. For example, you need to download the MEMS, just go into the MEMS path and download the release version. Yeah, it is very easy to use.
I want to ask a question about this MEMS. Is this it's a one branch of MicroPython?
Yes, we develop from the earlier version of MicroPython, and yeah, we are the branch of the MicroPython, and we have merged OpenMV's API to MEMS.
I see. So that if the student use MicroPython, I don't know, they can directly work on this program, or they have to use MEMS for programming of your module.
They are compatible.
Compatible.
Yeah.
That means if the student try to already use Python and MicroPython, and then maybe they have installed some library in the MicroPython, so that
yes, the library is also in Python code. It's script code, so it's just copy the PY, so just copy the PY field to the board. It is it's simple to install.
I see. Okay. Okay.
And here is the ID. We have make ID for make ID for MaxPy. You can download from here. Yeah, IDE. Well, the newest is this version. I have just installed this one. It is it is multi language. You can it is in the Chinese language now, and you can set it to English and any word you are using.
So I don't know if you can you quickly show our student how to install and this MaxiPy, and then how to use your module.
Oh, okay. Install.
Yeah.
Okay. So you download from this website. I can show you the download. Yeah, I just download this package. Then you can run, just double click and run it to install.
I see.
Yeah, I have it's just a next finish.
Okay.
It's very easy. When you finish it, and you can you can run from the Windows. We have Windows version, Linux version, and Mac version. Yeah, you can run in the three ways, and you just click.
How about it's possible you can also have a version for Android?
No, it's harder to development.
You know, some of Arduino people, they try to make Android version.
Oh, this I'm harder to imagine to coding on the Android.
I know it's more difficult. Yeah, but but no,
it is closed platform because it is right in Qt. Yeah.
I see. You know, now we have more people have. Everybody have smartphone, or either like Android phone or iPhone or something. So that if you have Android the platform, then you know it will be. I think it can help user to easily use your product.
Yeah.
No, it's my comment only.
Okay. Then after you install this IDE, and you can easily to use it. First you connect the cable to the computer and the board, and let me first check. Yeah. Where I have the you can see the USB to serial port. It is COM42. I have just run some application, so you can see some output. But we in the IDE, you just click the connect button, and it will auto connect. Now it is connect. IDE have two parts. The left part is the code editor. You can edit your code here, and it have highlight of the highlight of the language. The right part is image preview. It will show. I can start the. You can start the script to run the code here. Let me try. Okay, after okay, it is run. You can see the you can see the image in the IDE. It is very also it is show in the LCD. You can see I just show the LCD in the IDE.
So my question is, which module are you using now? Maxi 12 or which one?
Every module is okay.
Okay.
Yeah, it is software. Software is suitable for every hardware. Yeah.
I see.
And here is a serial terminal. You can see the terminal from the script. And also you can here have store I'm using Sipeed Max Dock now, and you can choose the border type from here, Taurus and select board. Every board is listed here. Yeah.
I see.
And you can change field to board. Change field to board is you can select the label field to the board, and here is some useful tools. And you can save open scripts to board boot.py. It means, for example, you can save these scripts to the board, and when next time you boot the board, it will auto run the boot.py to. For example, I will write the command and convert space to text. Yes. Yeah, and it will save scripts as boot.py. You will the bot will auto run these scripts when it's boot up. And you can run your application offline. Yeah. Also, we have also you can use normal terminal to code with the it is pretty you possible have used it for. You can see it's auto runs the boot.py when it's boot up, and you can use country C to stop it. In this terminal, you can do everything. You can do everything like MicroPython. For example, in import OS right next, you can press tab to the fields in this path, and you can type anything in this terminal. And here is our BS. The network is a little slow. You can better you.
I know that you have a big like a group in QQ, huh?
Yes.
So every day is more than 1,000 people.
Yeah. What have
about your Sipeed module? Yeah.
Yeah. We also have Telegram too. Telegram we have.
Oh,
Telegram.
I see.
Yeah. And we will show the getting started step. First, you in the get board we have Taobao ship. we have Taobao chip here. And also we have Seed Studio. Our product is on Seed Studio too.
I also saw your product can also bought from Amazon.com through the Seduno.
Oh yeah, yes.
Yeah. See, do you know they also sell your product on Amazon, Amazon.com. Yeah.
You mean Seduno?
Seduno. Yeah, it's the one you are talking about. Yeah.
I know.
Yeah.
Yeah, it's
Yeah.
And it's Taobao.
Yeah.
And you need an USB Type-C cable. We use USB Type-C cable because USB macro is a little out of time. USB Type-C cable is you can plug in USB Type-C cable in both sides. It's more convenient. And the macro SD card is optional. You can run your scripts from macro SD card. You can use from very low distance macro SD card to very high distance macro SD card. Yeah, and you can borrow our modules from Professor Lee.
I would bought a series of
yeah. We have plenty in stock. But before you use Spot, you need some basic knowledge. First, you need basic knowledge of Python or macro Python. Python is very easy to learn. You know the many children under 12 will learn Python too in the K-12 education. Many children are learning Python. Python is very easy to use and very useful.
Why the K-12 they have to learn Python? I don't why.
So in China, the Python is very popular in the K-12 education. Yeah, I have seen many students learn in and the basic knowledge of.
But from my point of view, I think the K-12 they should learn more mathematics first, and then talk about this kind of programming or Python or AI. If you don't have a good mathematics foundation, I think this kind of computer programming is not challenging. I think most difficult part is how you have good foundation in mathematics. Then you are able to do AI programming. This is my own view, but what's your comment?
Yeah, maybe the Chinese parents they want the children grow more faster, so they. Yeah. And in the other hand, you need the basic knowledge of electronic. For example, view the SSH and basic interface. You should have knowledge about basic interface like UART, IIC, IIS, PWM, and so on. It's very common in the Arduino or other projects.
For typical MEMS sensor, right? In your smartphone, we use I2C, SPI. Of course, for Arduino also provide PWM, right? For motor control and also LED. Yeah.
Yes, they are very common in such projects. Yeah. When you get your board, the first thing you need update MaxPy firmware, because we update MaxPy firmware very frequent. You can find the you can find the release version here. Yeah, the newest version is in master. You can see it's just update 2 weeks ago. And you can click the 10 to sort. It's the newest version is 0.5 version. It's released 2 weeks ago. The first thing you get about you is to update the framework. We update it very frequent. The method is, for example, I download. For example, I download one of them. It have several tabs. Minimal with ID support, and the normal version, and the normal version plus little VGL support version. Okay, it is downloaded. Okay, and now we can update the firmware. It use you should install the Flasher first. The Flasher, you can download the Flasher here. It's HGUI. It is the cross platform. You can download you can use it in Linux or Windows. I have just install it. It's
But I don't know if this one also have English version for it.
Yeah. No. When you click this icon, it can switch to English or to switch to Chinese. Okay, I reboot it and it will become English.
I see.
流水面。
And we change it to it will auto select in from your system language. So my system is Chinese, so it will auto select the Chinese. Then you can increase. You can add your you can add your framework. We just download the newest framework here and select it and select your board. The board I'm using is MaxDoc, and download to Flash. Choose the right port and the right baud rate. Baud rate, different board have different max speed of baud rate. The max dock speed is up to 2 mega bps, and choose the speed mode. Then we click to download. I see. The Sipeed is using the serial port, so it's a download field. We should close the Sipeed first. Yeah, close, and now we can download. Okay, it will download the ISP program first, then download the MaxPy firmware. Okay, it's a download success. We can connect. It can't show the version. We can connect in Qt and see what's the Qt version. We can see the older version is 0.4, and let me check if we update the firmware successful. Press Ctrl C to stop. We can see the version is up to 0.5, we have successfully updated the firmware. Yeah, it's very easy. Just select the firmware and download. After yeah, we have already introduced about install IDE. And here is some example of the basic control. For example, like the IDE, it's just for single lines code. K210 have FPLA. It can mix GPL to any function you want. We package those functions into FPLA manager and max. First, you register the pins. For example, in the board info, LEDR means red LED. So the pins connect to red LED. You first register these pins to GPL 0 function, and then you can use GPL to control these pins. For example, you first to set the GPL to output mode, and you can use LED value 0 to light up the LED, and value 1 to off the LED. It's the basic control. And here is some complex application about the breathing LED. It's use PWM to control the brightness of the LED. You can see you can init the PWM, use those two lines code, and in the tenor you can change the brightness every 15 milliseconds, and here is the demo code we just run in the IDE. Yeah, it is a hello world the demo code. It needs the camera and set the camera resolution to QVGA, and snap every picture and display in the LCD. Also will display in the IDE. This is a basic usage of the sensor. And now let's run some AI application. We can run the mobile net. Mobile net is the very basic AI network structure. It is very lightweight. It is about 2 or 3 megabyte size, and the Sipeed Max board can run mobile net in about 30 FPS. And we also have face recognition example. We can this module is on our platform called Max Hub. Can go to Max Hub. Yeah, here is Max Hub. So website. This website page the language is auto compatible with your system language selection. Yeah, here I have many examples of the module. You can download the module from this website. For example, the mobile net example. So you need to register this website and then you click download. Here is discuss. Discuss will go to the BBS post. You can see the see the introduction for this module. Yeah, and the demo code here is the demo code. Let's try it. You can click download. You need the machine code first. Machine code, you click help here, and you will know how to generate a machine code. You first download the key generator framework, and you use KeyFlash to download it. Then you will get the machine code. I have generated the machine code before. Just copy it and click.
So I want to ask, for this website is many user of this your company product will share this kind of their program, right?
Yes, the module is the module on this website. Some of the module is posted by our company, and some of the module is posted by users. You can see the you can see the module. For example, it is posted by Sipeed, and some simple some simple module is by user Dima. For example, it is now you.
I have a question for you, because I look at your company's account on Twitter. There's some user try to use your company product for a self-driving car.
Yeah.
So I don't know how difficult to use your company's AIoT module for this self-driving car, like a example.
Self-driving car is he doesn't use. I think he doesn't use the AI module, but uses the typical computer version API, because we have traditional OpenCV like API. You can see the video.
I think self-driving car is also very hot topic now in the industry in Silicon Valley, in China. So, but my question is, how it's possible to use your company product, right, for this kind of small, small like a model self-driving car?
Oh yes, self-driving car you can.
Because we do have I remember we do have one project team is working on self-driving cars. So if you can provide more information how your AIoT module for self-driving car project for our students, that would be great.
Yes, it's a self-driving car is mainly the main problem is to recognize the object on the road. So the
yeah, I understand. This is in real self-driving car on the street, right? So it's much more difficult. You need multiple sensor, right? You need this typical camera, and also maybe LiDAR with many other different sensor, and then try to. But for our project in our course, I think we simplify. We don't need to do such very ambitious this kind of self-driving cars. We can try to confine our scope, right? Do you think to be at least in our lab area in the classroom, and the student can demonstrate to use your company product for this simplify the self-driving car in one more in the lab area, not on the street. I don't think that's much more challenging. Yeah.
For example, I can open the Twitter.
I don't know if any maker in the world try to use your product for self-driving car, like a small, simplified small driving car example.
For example, in that Twitter video, it's a very simple example. It has a very clean road and only very simple object on the road. The MaxPy has the API for. I can just look at the API. OpenMV we will have merged OpenMV API and simply we just use image find length or image find length segments or image get regression to recognize the length in the road, and then when we can use the module to recognize objects on the road to avoid certain
So in the lab scale, right, for small self-driving car, if we bought this AIoT module, right, and then with additional camera, with additional MEMS motion sensor, and then so that you see how now good is it can self-driving car at different level, right? So that how I don't know in terms of computational power. So I don't know how good now your module can be used for this small lab scale the self-driving car. And then say for the like so those company, right, like NVIDIA, they try to make a much more aggressive the supercomputer AI for self-driving car, right? But I understand for your module, I hope that at least can be used for our like term project in our class. That would be great. Because I understand there's some limitation, but I can see still there has some proof of concept that prototype can be done with your company product.
Yes. It's easy to make the simple self-driving car. Our module can first you use the sensor to find the length and objects on the road, and you can make a decision to make car left or right turn direction, and I think it's easy to make this example. Okay, let's continue the. We just download its module. It's called MobileNet. Its module. Okay, then we can download. We can we can download this module. Every AI method is will need an module. We be here. And we choose the address. We can see this demo code. The address is 2 megabyte offset. We just copy this address. the module will flash to this address. Okay, everything is right. Okay, let's download. I will get to close the Qt. Oh. Okay, and now we download. And also we can copy this code. The model is very big. We need some time to download. Okay, finished. And now we can open the IDE and connect. And we just pass the code. We just copy from the BBS. Oh, it need a label tag. We need to download the label. Here is a label. Okay. Label, yeah. The label is every class name for Bennett. Then we can send transfer field to board. Select this field. Okay, and okay. And okay, let's run this script. Okay, going to run. Oh, I get to draw it on the main buffer. I need to change. Change to the. I will. I need net first. Okay. I need the drum on the it seems okay. I just in the IDE we can't see the results. I will just let me print. Print the name of the label in the terminal. Okay. Wait. Okay. I drawn the drawing on the LCD before, but you can't see the LCD display in the IDE, so we change the display to the terminal. Okay, we run. Okay. It's octopus as a classified result, but empty now, so it's octopus as the first number is the potential of the classified result because it is empty, so it is very low. It is very low potential. So we try to recognize some object. For example, we try to recognize
So your module now have pre-trained data, so it can really recognize tiger.
Yeah, you can see now as the right side. The right side is the tiger picture, and I just pressed the reset. Yeah, you can see it's a printers tiger result.
Then I also question because I have some research project about this, how we can capture the cancer cell from patient, and then so if we have a lot of this kind of cancer cell picture, and then so that we first maybe should use maybe Google TensorFlow to do training, right?
Yeah.
Can you tell us how can first, for example, I have a set of picture and use Google TensorFlow do the training, and then how can
we have more simple way, because if you use TensorFlow, it is a long lessons to teach. So we have more simple way to
if I use your platform, and how to, if I set a picture, right, like a cancer cell CTC, and how we can do this kind of training.
Here is a module training page. Here is a module training page. And it is very simple to use. We have the video on the YouTube. Maybe the speed is slow, so I try to.
I can. Oh, you also have. Okay, I understand. In China, use another.
Yeah. Hello. I have the. It is Chinese version. You can train your own video in our platform. This is First, we need prepare hardware.
Yeah.
Then you need take a picture for every object you want to recognize.
I see.
Yeah, it's better take more than 40 pictures in different background.
I see.
And we have you make move every task picture to one task. Yeah, and we have an script to auto process these pictures.
Okay.
Every task picture here. Then you package them together to CIP file and upload to our platform. First, you need the machine code. Machine code. Download the Flash GUI and select your board. And download the T-Gun, the key generator, get the machine code. And it will auto post to the platform and will send email to you. Send an email to your email. The first method is bound to your flash. It don't need a PF card. Select the board and the serial port. Download. And the second method is copy the module to the micro SD card. You first update your firmware. And copy the all file to your micro SD card. Then your board can boot from your micro SD card and run the script. Yeah. Also, you can show your module on the platform. You can fill in your module name and the class. And you can see your module will on our Max Hub. Yeah, this is a whole process, whole flow.
I see. Okay, so I would say it's much simpler compared with this Google TensorFlow. I see.
Yeah, you just take a picture and source the pictures and upload to our website.
Yeah, great. Another question is, how about the microphone, MEMS microphone for voice recognition? So that I don't know if you can also have a quick demo about this thing. Voice, right? That's another important application. Yeah.
We have very simple. I think in our Twitter have the demo and in the Twitter master login 改成为OK。Max do not have the simple voice rate. Here I have Max speech recognize. Simple, yeah, it's very it's a very simple lab. It only can recognize the sound. It can recognize your sound. It depends on person. It can recognize your sound, but it can't recognize other people's sound. It's a very simple demo. But we also have the commercial demo. Can recognize everybody command word.
How about, I know now this kind of voice recognition become more and more important now. See, can your AIoT module be connect to some of the big companies the server? For example, the Xunfei or those are company, right? Amazon, Alexa, so that I don't know if your AIoT module with MEMS microphone array can be used.
Yeah.
With this company server. AI
yeah,
server.
we have Wi-Fi on the board. The M1W module have Wi-Fi on board, so you can use the onboard Wi-Fi connected to the server and transfer the voice state.
So that means it's possible student can use your AIoT module to connect to this even Amazon Alexa server or the 科大讯飞 right?
Yeah, it is possible because we have Mac and have Wi-Fi.
That means they can make their homemade those kind of 智能音箱 right?
Yeah.
Oh, I see. Oh, then that'll be interesting. I believe some people interested make this kind of thing, right? Homemade DIY, because some of this, for example, Amazon Alexa is still quite expensive. If you can use your AIoT module to make a low cost DIY, you can see then I think you will have a lot more user and a lot of people want to buy your product.
Right. Here have the here is audio. It is sound field imaging. Yeah, you can see it can find the sound position. You can see in the LED or the LCD. It can location is the sound source. This is the of the audio application. And I can see some other for example, it is face recognition demo.
I see. Okay, I think thank you very much to give this kind of brief introduction of your product. I don't know if our student has any question or comment for our speaker.
Okay, if you have any question.
Any question you want to use their product for your project or something you want to try? Any question for our speaker? How about I have a question for you? If we develop our new sensor, for example, MEMS motion sensor, so that I know actually people in industry like ST Microelectronics, they try to make a MEMS motion sensor with machine learning. So that what's your comment about this kind of application, right? Of course, CMOS image sensor, computer vision, and MEMS microphone is one of the most mature way to use AI. How about this MEMS motion sensor?
MEMS motion
sensor, 惯性传感器. How we can use your AI for new application? Nature observation and just go things. What do you any comment?
You mean the 惯性传感器是 application?
Yes. Now at least for ST Microelectronics, actually they really make this kind of module now. Of course they claim they have a more low power like a MEMS sensor with this machine learning.
We have example. I remember human activity recognition. I have. You mean this application? It's a use.
Yes, yeah. Human activity, right? Yeah, right. Yeah. When people try to measure the human body motion or something. Maybe for VR, AR. So people move your hand, your head, and then so that how the man's this kind of inertial sensor, motion sensor can use AI for human motion, right? Posture or something, right? For VR, AR, MR.
Yeah. In this post this user discuss this application with me. He have changed the module to predict the human activity recognition. It is simple because every moment the sensor outputs 1, 2, 3, 4, 5. Also put six
Degree of freedom.
Yeah.
Yeah.
And the module will predict human state by this parameter. And the simplest way is predict state in use only current moment six number, and the advanced method is predict state by for example last second data. It's will about the 6 multiply maybe 10 or 100 symbols. Yeah. It is a kind of image recognition. It is another kind of image recognition. He have in this post he have implement this application.
I see.
Okay, so I have a question. Yeah. So what are these 6 parameters like? They are the acceleration data, or what are those? And second question is, where did the motion sensor is placed for this human activity recognition?
这个可以翻译一下吗？我刚没听。
Oh, Isa, can you repeat your question again?
Yeah, so my first question is, where is the motion sensor they placed it on the human body? Like it's in the pocket or on the hand, or where they placed? Yeah.
我的博士生问你是说，它这个惯性传感器啊，加速度或陀螺仪是放它这个人问你是放在人的哪一部分，身体的哪一部分？
It is from the it is here. It is open source data set. I can show.
可能你不知道它这个是一个已经开源的那个资料吧，是吧？这惯性传感器资料，他没有跟你讲是从怎么样获取这些那个数据的吧，传感器数据的吧？
这里没有讲，但是肯定是可以找到的，只是说他这里没有讲，这个是可以找到的，应该是。
So it's hard. So probably Mr. Wu didn't know exactly how this particular user tried to now put their motion sensor in human body. I think he only know that they had this kind, just like open source the data set.
Okay.
Oh, I found the original data source. It is from WISDM, wireless sensor data mining. It is from here. And in this website you can find the detail of the data. And if you are interested in this data, you can contact them. Yeah.
Okay. I see.
What's the second question?
Any other question for our speaker, Mr. Wu?
Hello, Professor. I have another question. I'm Hadi.
Please add. Yeah.
Okay. Is it possible to use this kind of AR chips as a DSP chip, for example, can they provide some built-in multipliers or dividers for the users or not? Is it for the DSP chips? DSP chips
okay.
provide some multipliers for the users that can use them for the digital signal processing. How about this kind of
hold on, let me ask one by one. So 我这个博士生是问说，像您的这个 IoT 的模块本身可不可以AI 这个芯片来用在做 DSP 啊？数据你知道？
我知道
DSP 的一些运算，就是特别有一些算法，它要一些高速的一些传感器的一些计算，数字方面的一些。
了解。This chip, we return to our PPT. I have the chip structure. You can see this PPT. If you want to use it in DSP application, first it have FPU. It have two individual FPU in double or single. Single pressure is used called float. Double is just called double.
Okay. Double precision floating point processor, right? So this is just like the one for DSP, right?
Yeah,
它可以做一些高速的一些运算嘛。Yeah.
And another way is to have hardware FFT. If you are interested in audio process, the hardware FFT will provide a very fast FFT speed. And it also have CNN accelerator, because if you can convert your DSP program to normal CNN application, it will much faster use KPU.
So Ishak, I don't know if he answered your question. And Hadi.
Yeah. And I got it.
Okay. Any other question, Hadi?
No. Thanks.
So of course, you see, in this particular AI chip, they also FFT. So
yeah. I see. It's really interesting.
No. From my point of view, it's very useful for what? Vibration analysis.
Yeah.
Once you have a major oscillation, angle velocity for mechanical vibration, so you can use FFT to do the frequency response analysis in real time.
Yes. It's very useful.
Xiaoyi, do you understand? Xiaoyi, are you online? Xiaoyi Huang?
Yes, we are online.
Do you say so that if you use this kind of the AI chip with the MEMS motion sensor, so that you can really do the real time motion, the FFT, right? Look at the vibration analysis in frequency domain. For example, if mechanical structure, right, you can building robot, or you have some vibration or some problem, and then you look at frequency domain and to see maybe the natural frequency shifting or some vibration mode have problem, then you can do some structural health monitoring. 这是建筑物或是一些机械结构的一些健康监测。This is one of very important application from my point of view. How can we use a MEMS motion sensor with this kind of AI? So 我自己认为这方面就 MEMS 的一些惯性传感器或运动传感器跟 AI 结合的话，它一定可以用在一些大楼或一些比如说高铁或一些车子的一些健康监测。
Right.
那到这边是结合我们机械 mechanical engineering. If you combine our mechanical engineering domain expert with AI, then for sure we can induce a new application of your company product.
Oh, right.
Because I go to have a project with Professor Li Weiling from UC Berkeley in the DZI present, right? 李泽湘那个大的，我们马上要启动一个大的这个项目，是做这个建筑业的4.0，工业4.0。How we construct this kind of building automation system, and then with sensor, with AI, with additional like vibration analysis, I'm pretty sure we can do this kind of safety, increase the safety of this building or safety of the mechanical structure. 这是我是从我们这个 mechanical 机械工程方面，我认为应该是有另外新的用途，对。Hello， 喂，我就
yeah，
对，我说的，of course now AI is much harder in computer vision， right？ 就是这些电脑视觉、人工这些 computer vision 还相关的这个 voice，right？voice 你可以 see 那这个声音的辨识嘛，所以一些小米音箱、亚马逊、Amazon、Alexa， all this is only two， but for the other sensor now with AI, I'm pretty sure there's a lot more application.
Yeah.
And then of course we also come with like 电化学传感器 right or 气体传感器 gas sensor. So if you have the multiple electrochemical sensor or multiple gas sensor, and with AI I think we can increase the performance of this kind of gas sensor or increase the specificity of this kind of electrochemical sensor. Yeah.
Yes.
So I don't know if we have other students have question for our speaker. Any question for our speaker? I think today we are very happy to get the Mr. Wu to share about his company's this kind of product and also about this application. I give some simple tutorial. Yeah. Any question from our student? Oh, I want to ask you about this. How much money do you spend to make this use TSMC 28 nanometer? 你们花了多少钱来研发这个系统
？It's cost much.
可能几千万，还是有没有要几千万吧？
如果只是说，因为这
MPW 是多少钱呢？28纳米的。
This company Kendryte very 非常激进，它是没有 MPW
啊。哇
He don't do the MPW. He just first time and success. Yeah.
哇，好，就多花了多少钱？因为28纳米应该是不太便宜吧？
就是这个流片钱是一部分，但更多的部分它芯片设计，包括这种人员的工资也很多，反正加起来肯定应该是上亿的。
上亿的，对，我知道开发这种人工智能芯片。你没有几千万到上亿是不可能的啦。对 ，Yeah. We just Mr. Wu just told us about how much money they spend to develop this kind of AI chip using TSM 28 nanometer. Probably at least 100 million RMB.
Yes.
No, I don't think many research lab in the university can afford. But for MPW is okay. 我们现在是用台积电那个180纳米嘛，那是还算 OK 啦。那你到28纳米那个钱流片 MPW 也不便宜啦。我的同事用65纳米的话，台积电是大概是MPW 一次就是要50万
人民币
28纳米的话，65纳米50万，就28应该更贵嘛。至少我估计有一次变成100万吧。
对，他们非常冒险，他们没有做 MPW， 直接就投片，一次就生产了100多 K。
哇 ，they're so rich. You know, this company making the ASIC chip for Bitcoin mining. They're so rich. They don't do MPW directly. No, order now STSM to make their product, and one time then successful. Oh my God, this is
amazing. This company just IPO,
Now they are super rich. Want to go to US IPO? Wow, they're super rich 是。当我另外想问，就是如果我自己团队用台积电工艺来开发新的 CMOS 的传感器，有没有可能跟你们合作啊？就是开发这种 就一方面有人工智能的这个模块，另一方面传感器结合在一起。因为我看硅谷有几家公司做这样子嘛，像那个我可以给你看嘛，就是这个方面把传感器跟这个 AI 结合在一起，一定有用的。
right， 对。
当然这个就我们用的传感器的技术一般没有到不需要到那么小，那个到28，我们一般是180纳米就够了。
是。
可是这等于说你用同一个工艺的话，可能就太浪费了。
一般是 SIP 吧。如果你对体积有要求的话，你是使用 SIP 去操纵吗？
哦 ，SIP system， 我知道。那我的博士生 Hardy 是在做这个 system in packaging，so that I think it's more practical if you want to integrate AI chip with this our MEMS sensor. It's more practical to the wafer level packaging, just like Hardy is working on, right? 3D IC integration, right? That means one layer you have MEMS sensor, CMOS MEMS sensor, one layer AI, and then you just can now 3D integration. What Heidi do, and I think much more practical because 28 nanometer, my God, too expensive for us. 那我的了解，我们可不可以拿到你们的裸片啊，来做
裸片应该可能是需要一些量吧，因为
我了解，
目前据我所知还没有。
当我们可以做 decap 啦，我们找那个厂可以帮，就给你们买一批的这个 AI 这个的芯片，以后呢，我们把它封装把它去掉了，然后再做在我们超进界面来做 3D IC 的集成的工艺。
做一些样片，应该还这样子应该可以吧？
我们有这样子买就是一些市面上的一些封装好芯片，把它做 decap 完，把那个封装去掉嘛，然后再做后续的加工嘛，对啊。
对。
这我认为这 3D IC 集成应该还是比较实际。对你讲没错，因为这个技术technology node 是差太多了，不可能it's impossible to integrate this kind of AI with MEMS sensor on the same die. That's too expensive. Yeah. But 3D IC, the one Hardy is working on, I'm pretty sure it's much more practical. Yeah.
对。对，主要是如果是体积特别严格的话，确实是 SIP 会比较方便。但如果对体积要求不是特别高的话，其实在电路板上集成也是可以的。
对，你讲没错。就当在做基本研究的时候，可能在做很小的电路板来做就够了啦。看是到什么样的的应用场景。我觉得这个我们搞工程应该是很实际嘛。看你不同的场合，可能短期还是用电路板程式来做，还是比较集成还好。对。I talked to Mr. Wu so that for us it's more in short term it's more practical to do integration of our MEMS sensor with the AI chip on the PCB board level.
Yeah.
Of course,
it's possible.
For research we can claim, right, so that once you have finished your fabrication process for your 3D IC, then at least in terms of published paper, for sure, you can demonstrate we are the first one in the world to do this kind of integration. In terms of research publication, it will be great. But of course, in the practical engineering, it's better to do this kind of on a PCB board. That's more practical. Yeah.
In future, we will do it. Thank you.
Yeah. Okay. Do we have any other question for our speaker? I think it's great to get a lot of this kind of information from him. Yeah.
It's wonderful. Thank you.
OK. 当然我今天很感谢这个实际上我是帮介绍你们这个产品。那当我们是学了很多，就是这里面很多学生可能还需要再一点时间来消化一下怎么样你们的用这些AIoT 的那个 ID 来做一些 project。对，当然以后我们当然是希望就是说我未来上课的话，我们多希望鼓励学员用你们的产品来做 AIoT 的一些 project 就是了。Yeah. OK. Okay. I think that today is almost the end of our guest lecture. So that any other question? If not, probably that's it for today's this guest lecture. Okay. Oh, thank you very much. Okay. Bye bye.
Okay. Bye.
Okay. Bye bye. Okay.
Bye bye.
Okay.